Hello everybody, my name is Jamie Burrows. I am Client Engagement Manager here at the Global CCS Institute. Welcome to this webinar from the Global CCS Institute, GasNova and Equinor. In particular, I'd like to give a very warm welcome to our international audience. We have attendees joining us from all over the world. This is the third in a series of presentations called Telling the Norwegian CCS Story. Today, we will receive a presentation regarding the Northern Lights project. To help reach the long-term climate goals of Norway and the EU cost effectively, the Norwegian government have established an objective to contribute to the development of carbon capture and storage. The Norwegian full chain CCS project, currently in the planning stage, is intended to demonstrate and increase trust in this important mitigation technology. In parallel, the project aims to show how government and different industries can collaborate to realise a full CCS chain. Northern Lights is the transport and storage element of the full chain project, developed by Equinor along with its partners Shell and Total. Designed around transportation of CO2 by ship, the storage facility will be easily accessible to emission sources in other European countries, helping to lower the barriers for future CCS projects across Europe. Details of the full chain project can be seen on a new website recently launched, ccsnorway.com. That's all one word. Let me now introduce today's presenter, Sverre Overa. Sverre is the project director for the Northern Lights project. He has managed large investment projects for Equinor for the last 20 years. Sverre's experience includes being the project manager for the design and construction phases of Technology Centre Mongstad, one of the world's leading capture demonstration facilities, and also acting as deputy project director on the Nyhamna expansion project for Ormen Lange. You're welcome to submit questions throughout the presentation today using the Questions tab on the GoToWebinar control panel shown on your screen. Questions will be moderated and posed at the end of the presentation. We may not be able to answer all questions today. However, we will endeavour to get through as many questions as possible in this session. I'll now hand across to Sverre to deliver his presentation.
Thank you, Jamie, and thank you for this opportunity to talk about the Northern Lights project, one of my favorite topics these days. I've organized my presentation into 3 parts. I'll talk a little bit about the framing and context initially, then some of the regulatory and commercial issues that face the establishment of a CO2 storage. And then I will go into the technical part and describe the facilities themselves, ending a little bit with what the future may be. The background, I think, is reasonably well known. We have the climate issue, and CCS as a technology is obviously not the answer to all questions, but it's definitely defined as a key solution that needs to be part of the mix. Many industries can turn to renewables, change raw materials, but not all. And this is where we see CCS have real merit in decarbonizing the difficult industries. These are cement, steel, waste incineration. There is also, of course, the possibility to have large-scale hydrogen production as long as you can manage the CO2 that comes from it when you do reforming from natural gas. In Norway, CCS is actually quite different than in many other countries. CCS has been applied successfully for more than 20 years. It's an accepted solution. It's accepted politically, it's accepted by the NGOs and by the population, and it's applied successfully. Equinor has, on Sleipner, been injecting CO2 since 1996, and for the last 10 years at the Snøhvit facility. And we have, as Jamie mentioned initially, the TCM test center that's been in operation also now for quite a few years. And why is this? It's quite simple. There is has been a political will to try to do something. There was an implementation of a carbon tax for the petroleum industry that directly led to the Sleipner and Snøhvit initiatives. And as for TCM, it's the result also of a political will to do something. This simple diagram and timeline shows some of the key activities within CCS that has taken place. TCM, as you can see, started all the way back in 2006, 2007. It was part of a larger project to try to establish CCS at a refinery at Mongstad in Norway. And it led to the formation of Gassnova, who is now the state entity responsible for the CO2 activities in Norway, whether they are research or implementation of larger projects such as Northern Lights. The full-scale demonstration project is an initiative by the Norwegian government in order to realize a full-scale project that can drive technology forward and lead to a climate solution that can be applied not only in Norway, but in Europe and in the world at large. One of the questions that we often get is, can we just do this? Can we store all these volumes? Will it not leak back up? We believe that the experience gained by more than 20 years at Sleipner and Snøhvit has given us a lot of confidence that this can be done. Our partners in this project, such as Shell and Total, also have experience from storing of CO2 and have similar experience there. The interesting thing here is that actually it gets safer over time. There are several mechanisms that will ensure that the CO2 stays down in the ground. Initially, it will be trapped within the rock, and there are non-permeable rock keeping the CO2 trapped. Then it will be trapped in the pores. It will be dissolved in the water that is there, and ultimately it will be trapped by what we call mineral trapping, where it's turned to rock eventually. The Norwegian Continental Shelf has been the source of significant hydrocarbon resources, but there is also huge amounts of porous rock that contains only water and that can be used for CO2 storage. The Norwegian Petroleum Directorate has mapped the resource basis on the Norwegian Continental Shelf, and it is maybe up to half of the possible storage potential in Europe located in the North Sea basin. No reservoirs are the same, so there is a lot of work needed to characterize and establish the suitability of each and every one of them. So we cannot simply start drilling. There is a lot of work to be done. And one of the things that we have been working on is to see what are the facilities that are best suited to utilize these underground reservoirs. The initial feasibility study was made a couple of years ago, and we looked at the different alternatives. We looked at direct injection. We looked at utilizing existing facilities that are currently used for hydrocarbon production. And we looked at having an onshore terminal with a pipeline out, essentially similar to some of the hydrocarbon developments that we have, but in reverse. And the conclusion was that we would go for an onshore terminal with a pipeline. The interesting thing about this concept is that we are then utilizing a ship to transport the CO2 from the capture site to a receiving terminal. This opens up for a very flexible concept, because ships can go essentially more or less anywhere. And it allows for smaller polluters to have an opening for delivering their CO2. Putting in place pipelines from every point source would be extremely costly. Using ships makes this much more flexible. This led to the concept that is currently in place for the Norwegian demonstration project. You have the capture plants. Currently, there are 2 capture plants being matured. It's a waste to energy plant at Fortum in Oslo, and Norcem cement factory in Brevik. Northern Lights as a project has the responsibility to pick up the captured CO2 using ships, transport it to the receiving facility on the west coast of Norway, and then safely deposit it underground, almost 3,000 meters below the seabed. There's quite a few differences. Equinor and the partners Shell and Total are oil and gas companies used to developing complex projects in the oil and gas industry. And when we do regular project development work, it's fairly well defined what we're working with. The resource being hydrocarbons, the market is existing. There is a market for oil and gas. There is a regulatory framework in place because oil and gas has been developed for well over 100 years. And the business case can be established, and the project can be refined through maturing through decision gates. And essentially, you can optimize and define the outcome. When you come to a CO2 value chain, it's much more difficult. There is no market, obviously, for CO2 in this context. The resource is not really defined. We know that there are large underground reservoirs suitable for storing CO2. We know that there are too much CO2 essentially, but there is no business case simply because CO2 is a waste product. It has no value as such, and the cost for managing it is higher than the quota price established. There are some regulatory frameworks established, both as EU regulations and national regulations, but these have not been tested. So whether or not they work is not really known. So it's very hard in this context to build viable business cases that will make CCS happen, which is why, of course, we don't see any CCS projects maturing really. One of the things that needs to be in place is a so-called exploitation permit. And Northern Lights received the first exploitation permit issued in January of this year. It's known as EL001 or exploitation permit 1 in Norwegian. And it is for a fairly large area south of what is known as the Troll gas field, west of Norway. And why is this huge area available in the North Sea, where you can see on the map that there are quite a lot of hydrocarbon fields? And the reason, obviously, is that this is an area with no oil and gas prospects. And when there are no oil and gas prospects, there have not been drilled any exploration wells. So there are no wells, and therefore limited knowledge and understanding of the subsurface. As I said, there are no commercial CCS projects there. And what we are trying to establish is a first of a kind full chain project that should be commercial, and it will be based on industrial emissions. And it will have one storage that is open and accessible for multiple industries. The alternative for the industry typically would be quotas, and the quota price simply is too low. And there are no other taxations or initiatives that drives this. So we need a public-private partnership where nation states come in to assist and bridge the financing gap. But it's also important that the model that is being established can be reused and lead to an industry, because we all recognize that for CCS to be part of the solution, there is a need for a fairly rapid ramp up in capacity and the number of facilities. What we see is this project needs to be phased. We cannot go for the capacity needed in the first step. We need to start by building volume to identify and get point sources involved and to deliver their emissions to us as for injection, and then build up volume as we progress. And we have quite clearly here the chicken and egg issue, where it's very hard to get industrial emitters to commit to establishing capture plants without having a storage. And we need actually to have commitment from emitters in order to justify building the storage. So it's a challenge. However, the opportunities are there, and we have looked at sources that are located with access to sea because of the ship transport part of the project, and we see there are many, and there are many sectors that could participate. And we're actually having a dialogue with quite a few of the emitters shown on this map today. So what is the concept for Northern Lights? This is a very busy slide, and I will only spend a short time on it. But essentially, it is a fairly simple, scalable system. The ships can have a certain capacity and can be used for one or more capture sites depending on the capacity and the frequency they are arriving at. We have this onshore receiving facility that is essentially only a tank facility for intermediate storage of the CO2. There is a pipeline. The pipeline is one of the higher cost items in the project, and we have therefore selected a high capacity in the pipeline to allow scale up. And we can see at the bottom, if you understand my graph here, that we're trying to show the capacity of the various parts of the chain. And you can see that the pipeline has a capacity of 5 million tons, which is significantly more than any of the other elements in the concept. And then obviously, ultimately, there is a well where the CO2 is injected, and additional wells can be added as needed. I mentioned cost. I will not go into the actual cost at this point because we are in the phase where we are defining the system and the associated cost. We have some initial estimates from the concept phase last year, and we see that the cost is distributed between the various elements of the project. And as you can see here, the onshore receiving terminal is one of the more costly items. Then it's pipeline, as I said. Subsea is the subsea facilities. There is the well, and there is the ship for transport, and there is some management on top of that, as there always is. There are some challenges with CO2. It's an interesting fluid or component to transport. It has 4 phases that we need to consider. It can be a gas, it can be a liquid as a fluid, it can be supercritical, or it can be solid, dry ice. And for us to transport it in an efficient way, we need it to be in the liquid phase. The unusual thing there, of course, is that it can move from the liquid phase directly to the solid phase if we are unfortunate. And in our project, we actually have it in 3 of these phases as part of what we want, but we do not want a solid phase. So we transport it liquid, cold, and pressurized, and this creates some challenges. For this purpose, we have had to design and develop a specific ship solution. So this is the ship design that we're working with. It will transport the CO2 at a moderate pressure of 15 bar and minus 25 degrees typically. This is comparable to what is being done today with CO2 for used for the beverages and so on. But those are much smaller volumes and much smaller ships. We need to scale this up, and we believe this is the largest size tanks and ship that can be used before we develop different transport conditions. One interesting aspect here is that since this is essentially an environmental project, we have selected to go for a hybrid ship propulsion with LNG for the engines and batteries to allow the ship to operate on electricity in the near-shore areas. So that's interesting. Then we have the receiving terminal itself, west of Bergen in Norway. As you can see from the illustration, it is essentially jetty facilities to allow the ship to unload its cargo and tank volume for intermediate storage, and then some simple buildings for administration and so on. The west coast of Norway, for those who do not know it, is challenging. It has very uneven seabed. And this shows a cross or side view essentially of the terminal, and seabed just outside of it. It's quite steep, goes quite deep, down to 500 meters of water depth quite rapidly. So there will actually be a need to drill a tunnel in which to place the initial part of the pipeline. From the terminal, which is on the right on this rather busy slide, the pipeline is the orange line going first north, which is up on this slide, and then left or west. All the other lines that you can see on this map are other pipelines or installations that already exist in the North Sea related to oil and gas developments. As you can see, it's a lot of activity in this area, and it's quite important that we coordinate with them in what we do. Just to illustrate some of the interesting challenges we face, this is in the near shore area, and it may be difficult to understand this, but this is the pipeline, is the orange line, and what you see is the mapping of the seabed that we have performed last year. It's detailed map by ROVs, and there are some specific issues. The seabed, as I mentioned, is extremely uneven, leading to a need to install rock to ensure that the pipeline is stable. We have a submarine, a German submarine from the Second World War, which was sunk in this location, and it contains large amounts of mercury, and we therefore need to be very careful not to disturb it or its immediate area. And of course, there are areas with corals that we are not allowed to damage. So these are some of the challenges we face in installing the pipeline itself. Then we also are going to receive some of our utilities, such as power and control for the subsea development from a nearby installation, and we need to do the necessary modifications and tie-ins to this as well. The subsea equipment, it looks like a small yellow thing on the map, but in reality it's a fairly large installation. This building that you see is the building that I'm sitting in now, and it's just there for scale to show the size of the first well structure. This structure is actually under construction in Poland at the moment, and in this photo you see the part that is marked blue in the drawing itself. So it's a small part of the larger structure. And it will be completed later this year, and then installed in October of this year. And this is just to show some of the vessels that we have had operating now this spring in March and April, doing the seabed and geotechnical surveys necessary in order to design the structure you saw on the previous page, and to also to plan the installation that we will perform. The first CO2 injection well, which is also an exploration well to determine that, or to confirm actually, that the reservoir is suitable, is planned to be drilled also later this year using this drilling rig known as West Hercules. So that's one of the more exciting things that we're looking forward to later this year. And then what is really needed to store CO2? Why are we drilling now? What we need is a place for the CO2 to be. and that means essentially what we call sand. In reality, it's sand originally, but now it's sandstone, which means that it's a fairly porous stone with pores that currently are water filled, where we will displace the water with CO2. We need fairly large areas of this sand, large volumes, because we're going to store substantial amounts of CO2 in it, and it needs to be have sufficient what we call injectivity, which means that it needs to be able to receive the CO2 and that it can flow away from the injection well. We also need that there is a shale or very tight rock formation above the sand to ensure that the CO2 do not migrate back so that it becomes a leakage to the seabed and then to the atmosphere. So this what we call cap rock is also needed. And of course, we need to be able to monitor what actually happens. We're not going to be running blind and just inject huge volumes of CO2 and hope that it stays where it should. Definitely not. One of the key things we are working on is the ability to monitor. And we have a strategy here, and it's simplified significantly in this illustration, where we will inject, we will monitor, and as long as everything is as it should be, that means that we can observe the CO2 where it should be, and it stays there, everything is fine. If it behaves different from expected, we will have to see why. If we understand why, we may have to do something to mitigate it. We may have to change where we inject and so on. If we do that and everything is done as we expect, then it's fine. Should it not be, then we will obviously stop injecting. We will not inject if we are unable to predict and understand what is happening. We believe this is quite doable. Our experience from Sleipner and Snøhvit indicates that this is something we can do with a reasonably high degree of certainty. Then moving towards the end of my presentation, one thing that is interesting to observe, I think, and it's something that we have come to realize as we have been working on this project, is that initially there was reluctance with emitters to discuss going forward with projects to look at capture, because there was no storage available, and storage is beyond their competence and beyond what they want to get involved in. We're seeing that the fact that we are developing this project and maturing it and bringing it closer to reality creates a lot of interest. And on the left of this illustration is what we call the funnel, where we mature possible suppliers of CO2 to the storage. And we see that as we progress the project towards better maturity, there are more and more possible emitters who find this to be something they should look into. So that's an interesting, and it's quite different from a regular oil and gas business, for example. The timeline that we're working on, we're working on the commercial model, obviously, because this needs to be something that can be sustainable, and we're maturing the technical part. We will drill our injection and confirmation well later this year, and then we will start approaching the market for contractors to actually execute and build ships and facilities. At the same time, the companies Equinor, Shell and Total will make their formal decision whether or not to proceed or not, which is going to be dependent on what the well brings and how the project looks when we get to the end of the year. It's a project that is dependent on and is quite dependent on actually government support, which means that this will need to go to the Norwegian Parliament for a round of discussion and ultimately for an approval. And then, if that is a positive decision there by the Norwegian government and the Norwegian state, then the intent is to start execution in 2021 and have startup by year end 2023. So that's the ambition. This is what we're sharing with potential customers, and as I said, we are traveling in Europe, having very interesting discussions, and there is something in the EU called a project of common interest. It's energy, transportation, and CO2 related projects that have interest across borders between member states. And at the moment, we have an application where we are together, in total 15 partners. A number of emitters have joined up with us in this application to the EU to be classified as a project of common interest. And we have also aligned ourselves with some of the other ongoing storage projects that are taking place at this point in time in Europe. So this is a network. We do hope that we can realize this over the coming years. And that will be, we think, a very good way to start CCS and build from there. That ends my presentation, and I'll then hand back to Jamie.
Excellent. Well, Sverre, thank you very much for your interesting presentation. We will now move on to attendee questions, which have been collected throughout your presentation. Sverre, I'd like to kick off with some of my own questions, if I may. Equinor has adjusted to the energy transition over many years and today is seen as one of the more forward-thinking energy companies. Why does Equinor see CCS as critical for our energy transition? And why is it important that major oil and gas companies play a role in the development of CCS?
It's a good question. Equinor, has moved from being an oil and gas company into being a broad energy company. We have oil and gas, but we also have renewable energy, and we have placed low carbon solutions as an integral part of our business and a key success parameter going forward. We do believe that having a strategy to provide low carbon solutions is a competitive advantage, and it will create value long term. Oil and gas companies are uniquely positioned because to tackle the challenge of CO2 storage, simply because we have the subsurface knowledge, we have the geology knowledge to actually turn around and utilize it to find suitable locations for storing of CO2 and also to manage it in a safe and sustainable manner.
Excellent. The Norwegian Full Chain project is clearly a very important CCS project for Norway as a whole. How might other European countries support?
It's a Norwegian initiative. it's an initiative to decarbonize Norway, obviously, but Norway is a small emitter globally. However, Norway sees that it can play a role in kickstarting CCS on behalf of Europe. So I think other Europeans or the European countries can support this by contributing, by supporting their emitters in trying to find the necessary solutions for carbon capture and help bridge the financing gap that exists as long as the ETS price is at the level it is and the cost for capture is what it is. We need a number of capture projects to start industrializing this and to bring the cost down. The cost for the first projects will be higher than for the later projects, and we need to start. We need to start now, and we need to build volume. The more projects, the better, and the projects will be in Europe. They will not be in Norway. We do not have the CO2 emissions to justify that. We need Europe to take part. But we can contribute with transport and storage. That we can.
Great. Let's imagine it's 10 years' time and Europe has a number of large-scale CCS facilities in operation. What do you think were the key steps taken to make that a reality?
Well, it plays back to my previous comment. I think in 10 years' time, if we are to have a number of large-scale projects, by then, we need to start now. Obviously, that the lead time to get large-scale projects from concept and feasibility level into operation is 5 to 7 years. So we need to start now, and we need to start small. What we see, everyone we talk to in the various industries across the industries, they want to make their own. To have their own experience with CCS, and they don't want to start with the mega projects because they are prohibitively costly, and if they fail, it would be a catastrophe for the company in question. They want to start with something that is moderately sized, and that fits perfectly with Northern Lights because moderately sized means maybe 100 to 500,000 tons a year of CO2. Excellently suitable for ship transport to Northern Lights storage facility, and it will give them experience with capture, with doing the necessary modifications and implementation into their facilities, whatever they are, and they will build on that to go to large scale. So the steps needed are, we need to deploy CCS at moderate scale in as many industries as possible to build experience and comfort and trust that this is doable, and also to bring the cost down.
Excellent, thank you, Sverre. How much CO2 is emitted by the ships that will be used to transport captured CO2, and has Equinor explored ways to mitigate those CO2 emissions from the ships?
Yes, we are looking at hydrogen as a fuel for ships. We think that is definitely part of the future, and then hydrogen produced in a way that does not lead to CO2 emissions, obviously. So if it's reformed natural gas, then there needs to be CO2 capture on that, and that needs to be stored. That is something we're exploring, but that is still a little bit too far in the future for the initial ships that we are looking at, which is why we're looking at what we consider the next best thing, which is LNG as the main fuel, and then batteries for nearshore operation and charging from onshore power. the emission itself, our current calculations indicate that we will emit CO2 if we have ships coming from the northern part of Europe or from the UK to our facility. We will emit approximately between 1 and 2% of our cargo CO2 on that trip.
Understood. Great, thank you. Another question related to the ships. Were any other ship class options available or considered so that a dedicated vessel did not need to be designed?
We looked at what was available, and there are actually some challenges, because at first glance it looks like an LNG ship or an LPG ship could be retrofitted directly. However, CO2 is slightly different. It has a higher pressure, which means that there is a different pressure rating essentially. And the only ships that we found that were directly usable were those being used to transport in the food industry today, and there are few of them, and they are very small. So that was found to be a unfeasible solution. We have also considered larger ships and a different transport condition. It would again be purpose-built, but much larger. However, to justify that, we would need to have larger CO2 sources than what we are currently expecting, and definitely larger than the Norwegian projects that are part of the full chain project that we're working.
Great, thank you. Several of the audience have asked some questions regarding the London Protocol. To summarize those, have there been considerations of the London Protocol which currently prohibits transboundary shipment of CO2?
Yeah, we are obviously aware of that. We are working together with Norwegian authorities to see how to resolve that issue. We have already opened the dialogue also with the relevant body. We do believe that this will be resolved in time for the first shipment to take place. So we're aware of it. We do not see this as a showstopper at all.
Excellent, excellent. I'm certainly aware that there is a lot of work, a lot of discussion in the background around how to progress solutions to the London Protocol currently. So moving on to the next question. Are there plans to source CO2 from inland CO2 emitters?
We are actually some of the emitters we are in dialogue with are inland but located on rivers. So the answer to that is yes. We have also had a discussion related to truck transport. The challenge, of course, is that for CCS to be a climate change mitigating tool, the volumes are such that land transport by trucks or train is really not the solution. It is definitely an opportunity for initial pilots and demonstration plans, but for significant let's call it production capture, that doesn't work. Then you need either ship, or next phase obviously will be pipeline transport. But yes, we are in dialogue with land-based industrial sources as well.
Great. The next question here is, since you are sourcing CO2 from different sources, are the CO2 emitters required to purify the CO2 to the same quality before shipping?
We have established what we call a CO2 specification that should apply. We have tried to make it as, let's call it, flexible as we can. But it should be noted that we are not transporting in gas phase or vapor phase. We are transporting in liquid phase, which means that it has to be liquefied, meaning cooled down. And there is actually rather limited what it will be possible to include in liquid CO2. But we have a general specification that should work for most emitters, and I don't know if that was the answer you wanted, but
that was great. Thank you. Thank you. So the next question: to what extent is CO2 suppliers' commitment necessary for the investment decision?
That is a good question. You can say that we recognize that it will be very close to impossible for emitters to commit to initiate significant capture projects and deliver CO2 before there is certainty that there will be a storage project. So we think that what we will need, both for the industrial partners and for the Norwegian state, is a fairly clear statement of intent that is likely. But the number of emitters and the volumes that needs to be, let's say, agreed to work with remains to be seen. But some sort of intent from one or more non-Norwegian emitters is likely to be required.
Great, thank you. We just have time for one or two more questions here. So the next question that I have is, when will the Northern Lights project be in a position to accept CO2?
There's a number of things that need to fall in place, obviously. We need the well that we're drilling to give no surprises, no negative surprises. We need to have, as we just talked about, we need to have emitters confirming their intent to move forward. Given that all that falls into place, the best we can do is to be ready by the end of 2023.
Great. Well, Sverre, thank you very much for answering the various questions that have been raised. Unfortunately, we haven't been able to get through all of the questions in the allocated time today. However, if you still have questions, you will be able to submit them to the Institute using the email address shown here on the screen. Today's webinar has been recorded and will be made available on our website in the coming days. Sverre, thank you again for your very comprehensive presentation and your responses to today's questions. It's great to hear about the progress that's being made there in Norway, and I think we would all be very interested in learning more as the project progresses. We certainly hope that you found today's webinar valuable. This is one of a series of expert webinars hosted by the Institute. If you have not already done so, please sign up to our mailing list to hear more about future webinars and the latest news on CCS. Finally, as you are leaving today's session, we would be very grateful if you would take the time to complete a short 3-question survey to help us to improve our webinar program. Thank you all for joining today's session today, and goodbye.